Hi, Amanda. I see this question is correct here. I'm not sure why you think you're incorrect, but I'll just go through how the whole idea of level of confidence works and how we get the z-score. First of all, if you have an 81% level of confidence, that means if I'm looking at the standard normal curve, which is that nice bell shape, that I have two z-scores, a negative and a positive, and the area between those two z-scores is 0.81. So you asked about where in the text to find this. Since this is sections 9.1, we'd want to go to 9.1 in the e-text. So if you go to the Pearson e-text, which you can also access from Brightspace, so go to the learning modules, then go to MyStatLab, and then towards the bottom of that menu, you'll see the Pearson e-text. We can go right to chapter 9, and then 9.1 is estimating a population parameter. So to just give you an idea of what I'm talking about here, okay, this is obtaining a point estimate, which is just basically the percentage of the sample. Let me see where I can find it here. I'm sorry if I'm making you dizzy. Here we go. Okay, so this is an example of being 95% confident. So 95% of the area is in the middle of this normal distribution, and then there'll be a z-score here and a z-score here, where that is kind of the boundaries for that 0.81 area. Okay, now you can find this in a couple of different ways. To be able to get this quickly, it's really nice to be able to do this in StatCrunch. So if you go to your screen here, okay, under question help, I can click StatCrunch from here, and it will bring me right to StatCrunch, which is a great tool for calculating in statistics. Now, in order to figure out that z-score, we're going to kind of work the normal calculator a bit backwards. So we'll go to Stat, Calculators, go down to the normal calculator, and you'll see you have this nice pretty little bell curve. Now again, I said that 81% confidence is that 0.81 is the area between two values, so we'll use between. Now here, since my mean is 0 and my standard deviation is 1, this is the normal curve, the standard normal curve, because that's the definition of the standard normal curve. Mean of 0, standard deviation of 1. These would be the two z-scores. So right now it's saying that the area between the z-score -1 and 1 is about 0.68. We want the two z-scores that's going to get us 0.81. So what I'm going to do here is I'm going to clear this out, and I'm going to type in 0.81. And it gives me two z-scores. It gives me -0.3106 and positive 1.3106. So you would always go ahead and write down the positive value, and we round to the hundredths place, which is 2 decimal places. So that's how we got the 1.31. Okay, now you mentioned wanting to be able to do it by hand and where the normal table is. So there's two places to find the normal table. If you go to the Pearson eText, okay, if you go to Appendix A in the table of contents, these are all of your tables. I believe it's page like A11 or 13. So let me see here. I'm going to just type in A-11 and see if it brings it up. And here it is. Yeah. So I think that it may be 10 and 11. Let me just go back one page. Nope, it's 11 and 12. So here's the negative side of the distribution, and then you have the positive side of the distribution. It's just loading here. So there's your positive side, your positive z-scores. Now to make it a little bit easier for you, I did put a PDF of the standard normal distribution in one of your announcements. And so if you go to your announcements, in the announcement entitled Wrapping Up Week 2, if you go all the way to the bottom here, I have the standard normal table as a PDF. So if I open it here, it's a nice little PDF version. It's the exact same numbers, and it has the positive and negative, and you could save this to your desktop and not have to always go to that appendix. So that's a really great option. Okay, so now say I want to go ahead and calculate this, this by hand. I want to know how to get, StatCrunch is great, but how do I get this z-score by hand? So what I want you to think of is you have 81% between these two values, right? So I'm going to go back to my e-text really quickly. And I think we were on 9.1 where we found that nice little picture. So I want to at least show you the picture here to make it a little easier. Okay, so we have 0.81 would be right in the middle here. Okay, now remember that the area underneath this curve, right, is 1. Okay, so the entire area underneath is 1. Okay, so if there is 0.81 in the middle, I have to think to myself, how much is left over for the two smaller pieces here? So that would be 100 minus 81. Okay, and 100 minus 81 gets us 19, right? So then I say, okay, but this is a symmetric curve. So I'm going to take that 19 and I'm going to go ahead and I'm going to cut it in half. So I do 100 minus 81 to get those two little pieces. Divide that in 2, and that means it's 9.5% for each one of these little pieces right here. Now remember that your standard normal table, if you look, it only finds areas to the left. So we're going to be looking for an area of 9.5%, or as a decimal, 0.095, in our table and find the corresponding z-score. And that will get us this negative score, which then will actually record the positive score. Okay? But they're the same because this is a symmetric curve. You have a positive, you have a negative. So what I'm going to do, because I'm looking for an area, if I were looking up a z-score, I'd be looking on the side and on the top. But I'm actually looking for an area. And again, I want 9.5%, which is 0.095. So I'm going to be looking in the table for as close as I can get to 0.095. And so I'm going to scan through here, and I see the 0.09s happening. And here I have 0.090, 0.091, 0.093. Oh, and look, 0.0951. And that's going to be close enough. And then I'll look to the side, and I have negative 1.3. And I look up, and I have the 1. So that makes negative 1.31. So we'll record the positive 1.31. And that's how you would get the answer by hand. So I hope that helps. I would try just a similar problem to try that out. If you go to your problem set, anytime you'd like to practice something again, you can go to similar question down the bottom and try it again. So feel free, and if you have any more questions on this, just let me know.